What's going on YouTube? My name is Divesh Advani and I welcome you to my YouTube channel. So guys, I'm super excited to tell you that from this particular moment onwards, we are starting off with a new series. The name of this series is Agentic Memory. Now, agentic memory is very important when we talk about increasing the performance of your AI agents, increasing the reliability, increasing the usability of your AI agents. So let us go ahead and quickly start understanding about why we need agentic memory in the first place. Now, why do we need agentic memory and what is agentic memory? Everything we will understand. All right. A very simple example of this. If I just quickly open ChatGPT and if I tell ChatGPT, my name my name is Divesh and I need to learn agentic AI. Okay. Now, given my name, it gave me a response, right? But now, if I tell this AI that what's my name and what I am trying to learn. So let us see what kind of reply we get. You're trying to learn agentic AI, your name is Divesh. Okay, so we understand that it is remembering memory. This is a short term memory. Okay, if I show you this chat is a pretty long chat. Okay, see, this is a pretty long chat. All right. And if I ask, what is my first message? See, it will tell us about my first message. Do a deep research in AI and helping finding patterns. All right. So this was an example of long-term memory where it is able to retrieve information of longer duration as well. And the first example which we saw, learn agentic AI, this was an example of short-term memory as well, where we were able to retrieve information of short conversations as well, right? So what exactly are we seeing? We are understanding that in order to have a good AI, in order to make an efficient AI system, memory is very important. If memory is not there, there will be no flow of the conversation. So AI will just be a content generator and never be a our coding partner or a video generator, or it will never be a part of our human ecosystem. We can never integrate it in our workflows if AI is not making maintaining its memory. All right. So this is the whole importance of we studying the agentic memory, that why AI agents need to have a memory part in them. Now, if I show you this particular agentic loop, how this agentic loop works is there is a user, and this is the most standard workflow of a basic AI agent. All right, this is the root AI agent. This is the first AI agent which we always create. So a user can give a message. Let us say in the tools, we have made a tool to search information in the databases. All right. And this AI agent is a HR policy agent. An HR policy agent can retrieve all the HR policy related information. Now, the moment user asks, tell me about the vacation policies. The moment user has asked this message, the large language model will think, is the user trying to make a conversation? Is the user telling his name or conversation? He's trying to make a conversation. Or is he asking me some HR related assistance? So question about vacation policy is a HR related assistance. In this scenario, the LLM will go to the tool. The tool will give all the information. Okay, this information is nothing but the context. We call it as context, the context about the vacation. And once AI has the context, AI can give a response to the user that, hey, this is the vacation policy. Now, AI was only able to give a accurate, validated answer because the information which was retrieved was from a valid source, trusted source, and the main part was the information was retrieved from the tool. Okay. In this scenario, internally in the backend, we have also given a instruction to this AI that, hey, you are a HR policy assistant. Only answer the questions of users in under 300 words. you will always use the database to answer the questions. So what are these? These are system instructions which we have given this particular AI agent to remember the flow, to remember who he is, or to remember how to behave in the environment. All right. And this is the most basic agentic flow. We are still not coming to the memory part. This is one particular flow. Okay. In this one flow, what all things we observed? Okay. So the things we observed are in the form of messages. What we understood over here is information was flowing. Let us quickly identify what kind of information was flowing so that we can understand this better. Okay. So the information which was flowing is, first a user message came into the picture. Okay. Second, system instructions came into the picture. The LLM was given some instructions in order to how to behave. Third, the information from tools was received. Okay, this is the third thing coming into the picture. And fourth thing is the response which is being sent back to the user. We can observe four such things over here. All right. Now, what are these? These are different messages and they are defined technically in an agentic flow. So let us first understand these messages, then only we can go to understand the memory part. Okay. So every time an AI agent is running, multiple kind of messages come into the picture. These are the four kind of messages which come. The very first message is user message. Now this user message is nothing but the query which user is giving to AI agent. For example, if we are working with a website generator, example Lovable. So to Lovable, we will give a prompt that I want to make a website for my edtech platform or for my consultancy or my resume portfolio. All right. Now, second one is system message. Okay. System message is nothing but the instructions which we have given. And these instructions is nothing but prompt engineering which we have done internally. This is prompt engineering where we instruct our AI to behave in a certain way. Then we have tool message. Okay. Now this tool message is the information retrieved from the external functionality or external tool which AI use to get context from. Get context from, right? The contextual information. Now, what is this context about? This context is about the information regarding the query which was passed by the user. If query was asking about the vacation policies, so AI got the context about vacation policies from the database. And after this was received, tool message was received. The last type of message is AI message, which is nothing but a response to the user. Okay, and these are the four kind of messages which come into the picture: user message, AI message, system message, and tool message. So for every agentic loop, this all messages is considered as a turn. Okay, this all messages is considered as a turn. One turn. Okay, in one turn, four messages come into the picture. What do I really mean by this? Okay, what is this turn I am talking about? Okay, we all know that this is a HR policy agent, and we all have understood different kind of messages, right? These are all the different kind of messages, and we have understood this flow as well. Now in this flow, we have understood this clearly that once user message has come, system instructions will be given, tool message will be retrieved, and response will be given back to the user. Now this entire workflow, this entire thing which happened is called one turn. Okay, one turn of AI agent. If we give second message, okay, new message has come into the picture, a new question. The first question was regarding vacation policy. Next question was regarding leave policy. This is a next question. Again, for this question, this entire loop will run, and these all four things will come into the picture. So that will be second turn, turn number 2. Okay. So the whole point of telling you about what is a turn and what are different kind of tool messages or different kind of messages which an AI agent takes as input or which agent maintains are all essential for contributing into memory. Now, what do I mean by this line now? In an agentic memory, AI is remembering the information in turns. Okay, in turns, because in every turn there will be a user message, AI message, human message, and tool message. So AI has to not only remember what the user gave, but it also has to remember what was the instruction and what was the tool information and everything. So AI has to not remember messages, AI has to remember turns. So how an AI agent will maintain its memory? If I simply draw an AI agent, and this is the brain of AI agent, and in the brain, along with the brain, there is something called as memory of AI agent, and in this memory, it is trying to maintain a list of turns: turn 1, turn 2, turn 3. So similarly and so on, it is maintaining a lot of turns. Okay, now this turn is a context for the brain. All right, if this is you, and you are at a location X and you want to reach to a location Y, this is where you live. Now in your journey there are multiple turns. First you have to turn right, then you are here, then you have to go straight up, then you have to take a turn, and then you will have to come here, and then finally you can go home, right? Now you will only be able to take a turn when you remember where exactly you want to go. Okay, or you know from where you are coming. You know that from here you are supposed to take a right turn, and from here also you are supposed to take a right turn. How do you remember that? You remember that you are supposed to take a right turn because you remember where did you come from and where are you going. So just how a human maintains its memory, humans are called stateful. Okay, this is very important, and we have tried our best in the research paradigm to make AI agents also stateful. We have to make AI agents stateful. Why? Because let us take an example of a coding assistant. Okay, if you talk about some coding assistants like GitHub Copilot or Claude Code, or there is something called as Google Anti-Gravity as well, or Codex, there is ton of them. Now how it works is, how they work is, they don't take an image, they don't take a text, or they don't take these small things as input. This is already there. Okay, user will give input in these forms only: text, image, and etc. But a bigger thing which they take is a folder. We run these coding assistants in a folder. In a folder there can be 1000 files. So an AI agent has to maintain its memory across 1000 files. All right. Now, if I am a human, okay, and if I show you some code, this is a code. If I am a human, okay, I will not remember that in which file, which exact code is there. Okay, I will not remember that. In which exact file, where exactly which word is written, I will not remember that. Okay, so for that, I will maintain something called as README file. In that README file, I have kept it written that here you will go here. For finding this, you will go here. So what I'm doing, I am developing different techniques to maintain my memory. Okay, to sharpen my memory or keep my memory fresh. Okay. So now to the techniques to maintain your memory, to always stay up to date, is called as context engineering. This is another topic of discussion. We will do it at some another time, context engineering. But this is also very important. Okay. Now, why context engineering is important? Understand this part. Now, AI agent is trying to remember information in term of turns. Okay, every turn. Okay, let us say 10 turns it will remember. But what if we have 1000 turns? If AI agent is trying to remember 1000 turns, first token cost will blow up. Okay, AI agents will have a huge token cost, and while coming to the 1000th turn, These all turns will be forgotten by an AI agent because there are so many turns, right? There is so much of information. How can an computer program can remember all of this? So to manage all of this information in an efficient way so that the memory doesn't blow up, there are different techniques, and that technique is called as context engineering. Okay, prompt engineering is a different thing. Prompt engineering is a part where we instruct our AI agent how it is supposed to behave. But context engineering is a part where we manage how AI agent is maintaining its memory across a single agent or multiple agents, right? And this is what context engineering is all about. We will not understand context engineering now, but this was just an introduction to context engineering, which is coming into the picture in some while. Okay, now we are totally focusing on the memory of AI agent. So now that we understand what is agentic memory, the need of agentic memory, different kind of messages, now let us go ahead and understand the different types of memory. Currently, we have come a very long way, very long way in the concept of memory. We have developed graph based memories, which is the most advanced way of maintaining memories. But understanding all of them at this particular point of time is not worth it, because if we don't know the history, if we don't know the base of how the memory concept started, we will never be able to understand how this particular current state of the art systems work. We will have to understand the history, and once the basics are clear, and we have a clear bridge between what how it started and where we are currently, that is when we will be able to bring innovation into the picture. Now there are more than 30 techniques to maintain your memory. Now these all 30 techniques is history, and it is not the case that you don't need all these techniques. You need all these techniques. You combine these techniques to make hybrids of these techniques. Everything will make sense. Okay, so that is why for bringing innovation into the world, you need to know the history behind all the memories. So now I will go ahead and tell you about the history, and before that let me also show you some research papers which you should do as an assignment. All right, so let me go here. This is a research paper which is published on 13 Jan 2026, Memory in the Age of AI Agents. This particular research paper covers everything from the scratch. Okay, LLM based agent systems. So, just how I started to talk about this particular loop over here. I started with telling you about this loop, right? Similarly, this research paper will also start to tell you about all of these systems. And then it will start to tell you flat memory, hierarchical memory, and then many other, the complete ground basics of the memory will be covered, benchmarks and everything. Okay, so sometime you should give it a try. Then this is the history and this is the state of the art. See, it is published on 16th April 2026, which is very recent. A new research paper is come, Magma, a multi-graph based agentic memory architecture for AI agents. We can just quickly see how things are looking like. See, agentic LLM, retrieval prompt, update answer, memory dynamically evolving. So, what is all of this? Okay, and is your current state of the art systems, for example, Cloud Code, working like that? Okay, so none of this will be making sense to us. What is this intent aware router? What is this adaptive topological retrieval? What is semantic? What is entity? We will never understand this. What is this? What is the role of this vector database? We might know what is vector database, but what is the role of vector database in memory? We don't know that, right? So to reach to the current state of the art, that what is happening currently, we will have to go in the past to understand what happened exactly, so that we can, you know, bridge our gap between history and current scenarios. So I am going here, and now we will cover different forms of memory. Amazing, students. So now your ground is set properly. You know the base, that why we need to understand agentic memory in the first place. With this understanding, let us quickly go ahead and understand the different types of basic memories. This will be provided to you. What are we studying? We will see different types of memory: buffer memory, sliding window memory, summary buffer, token, vector store, entity memory, and then lastly we will compare all of these memories. So let us go ahead and understand this. What is this? This is a hands-on playground for one big question. When a chatbot remembers something you said earlier, how does it actually work under the cost, under a proper cost? Okay, so here we will use a trick to test memory. We have two people into the picture. One is a user, okay, which is us, and one is our AI agent Noah. Okay, Noah is the AI agent which we have programmed, to which we will interact in this particular video. So let us go ahead and understand. First, let us see the problem. Okay, what if there is no memory? In the scenario where there is no memory, how it works is, earlier AI agents only had one thing: brain. Okay, and let us say also tools. There was no concept of memory earlier. So how used to work is, whenever an AI agent used to give a message, it was directly given to the brain and the response was generated from the brain. If we ask a follow up question, okay, the AI agent was incapable of answering this follow up question. What do I mean by that? Okay, let us understand this via scenario. So this is a very interactive demo, you can run it. If I now give a message that, hi, I am Maya, nice to meet you, it is going to tell me, it is going to give me a response, hi Maya, it's lovely to meet you. If I simply ask, what is agentic AI? Okay, it is going to tell me agentic AI is this. Now if I ask, okay, now if I ask this particular question, what's my name? Okay, it's going to tell me we haven't had a complete chance to introduce properly ourselves. I just told what's my name, Maya, but it is not able to recall my name because there is no concept of memory over here. Let us look at more things. API request, three times our LLM was called: 1, 2, and 3. Okay, that is why we have 3 API requests. These were the number of tokens, 243. If you count all of this, each word from this, if you count each word from this, each of these words, if you count, they will sum up to 243. So tokens means the words in the sentences. Okay, 243 tokens were sent in and 108 tokens were received as input. And this was the cost involved so far. Now cost is really down because we are using a free API which is Grok. So internally when you are configuring your app, you have to enter Grok API. All right. And here you can also change the models to see the cost of the models. Different models will have different costs. All right. So we will see all of that, but I hope you understand that because there is no memory concept, it is not able to get a follow up question. If I am working with a coding agent and if I will tell that revert the previous changes, whatever you have made, you did something wrong, the coding agent will not be able to remember what did I do wrong, and it will never be able to correct the mistake. All right, and it will never be a coding agent then. Then it will be only a code advisor. All right. So best thing is it is free and instant. There is no memory to store, manage or pay for. Memory also comes up with a cost, but because there is no memory, there is no price. But the worst thing is it forgets everything the moment you say it. Not even forget even 1 second. It will forget the moment your message is out and the response is given. All right. So this is the problem with no memory. Let us go for the first type of memory, which is buffer memory. Okay. One more thing to show you, if there is something over here, what exactly it reads every time a new query comes. See, there is only one system message and there is only one user message. Every time we will give a new query. Okay. Even if I give something called as hi right now, okay, this hi will be treated separately. Check this out. System message. So internally, we will always give instructions to our AI agent that you are Nova, a warm, cheerful AI buddy. And this is a system message. And this is the user message. Every time this new message will be isolated. Okay. And yes, this is the problem with AI agents having no memory. All right. So that now that you know what is the problem with having no memory, let us go ahead and understand the solutions. These are all the different solutions, the historical solutions, all right, and these are still used somewhere somehow, in prototypes, in proof of concept works. So let us go ahead and understand the first kind of memory. This is the first kind of solution which humans came up with. The name of this technique to maintain the memory of AI agent is conversational buffer memory. How this works? How this works, let me give you one liner. Conversational memory. Okay. Conversational buffer memory. Okay. How it works is we remember in one turn there are four messages: AI message, system message, user message, and tool message. Okay. So what we do is we go on maintaining turns after turns. Turn 1, turn 2, turn 3, turn 4, turn 5. As simple as that. We just maintain the history of all the turns. What is the problem with this? The way that these turns are going on increasing and increasing, our cost is going exponentially high. Okay, exponentially high our costs are going. Why? Okay, because there is no logic behind this. We are just storing the history on and on. We are dumping the history. So let us see that in action. Now see, but memory will be maintained. Okay, memory will be maintained. It is a technique. Memory will be maintained, but it will blow up. Okay, so the first question was, hi, I am Maya, it's nice to meet you. If we ask second question, what's my name, it's going to tell me your name is Maya, I'm glad we are chatting together. Third, I have a pet whose name I have a cat whose name is Whiskers, she is super fluffy. And now if I give some different message, what is a fun fact about octopuses, what is the tallest mountain. Okay, if I give all of these messages and then finally ask what is my cat's name, okay, it's going to remember all of this. See, earlier it was remembering your name is Maya. This time it will also remember the name of my cat, Whiskers. Okay, so memory is working. We have successfully maintained memory, but look at the tokens and look at how the cost is blowing up. Okay, currently we are on the free plan. That is why this cost is not so up. But when you use paid APIs, for example, OpenAI or Claude, this will go next level. Okay, next level. And let us see how messages are being stored internally. See, system message, user message, AI message, then user message, then AI message, then user message, then AI message, user message, AI message. This all is being stored. Actually, this is also passed every time, system message, but only for demonstration purposes, I have just pinned it on the top. But every time user and AI message is passed. Okay, so we can see that we are simply dumping all the chats in one window, and that is called as conversational buffer memory. As simple as that. And what do you mean by this word buffer? The word buffer means list. Okay, so we are just dumping the chats, dumping the user queries and the responses into a list and of the conversation. So that is why the name is conversational buffer memory. The best thing is it will never forget anything. Perfect recall, and every single time it will, give you a good response. But if your turns have blowed up to 100 turns, then it will mess up your responses. Okay, or there will be some hallucination involved. The worst thing is this gets slower because this window will go on getting bigger and bigger. Okay, so this gets slower over time, the responses are slower, and cost is expensive. Okay, the costs are next level, the cost will go exponentially high directly. All right, so this was the first technique, conversational buffer memory, and the drawback of the memory, that it is very very costly. Okay, to solve this, people came up with a new technique called as sliding window memory. Okay, what is this sliding window memory? Let me go ahead and tell you. Sliding window memory. Now, in the sliding window, earlier just how we were dumping the list of turns one after the other, now what we do is, in order to keep a tight control over your cost, what we do is we are still doing the same. We are still dumping our chats, we are still dumping the conversation, but here we set a threshold. We set a limit that, after 5 messages, the rest of the messages should be evicted. Okay, what do I mean by that? So, first message is hi, this is me. Second message is what is my name, it will remember. Third message, fourth message, fifth message. 5 messages is my capacity. The moment sixth message has come into the picture, the first message will be evicted. Okay, I am saying evicted from this, but not, deleted. Okay, deleted is different and evicted is different. Okay, I will talk about it. So it is evicted from this. Okay, so that we only maintain a 5 message sliding window. Let us see that in action. All right. If I keep a window size of 2, let me show you this particular example. Hi, my name is Divesh and my salary is 30,000. Okay, I'm just giving it a message. Hi Devesh, it's nice to meet you. How much is my salary? It will remember my salary as well. Okay. See, currently our sliding window is 2, which means the moment third message will come, it will be evicted. Let us see how it looks under the hood. You can see tokens are also here. Under the hood, system message, user message, Nova message, and user message. How much is my salary? Let me give one more example. I also save 500 every month. Okay. So that's something smart. Setting aside 500 is overtime. Let us go and see what's happening inside. So this is also maintained. Okay. What's fallen out of the window? Message. 2 messages are evicted so far. Okay. If I give one more message, or if I just quickly ask, what is my salary? It will tell you earn 30,000 per year, which is a decent income, and you are also saving 500 each month. Okay. Now I will say, what is my name? Okay. What is my name? Let us see. I don't think we have discussed your name. So what exactly happened? Okay. Because we are evicting the messages. Okay. We are evicting the messages. So you can see over here, I say 500 and this. What we have lost over here is the system messages. Sorry, the user message. Earlier we did give it a message that, hey, I'm earning 30,000, etc. So this it was able to remember because it was still in the window. But once we go out of the window, once that message is evicted, it will not remember the name. Okay, or it will not remember the previous chat. Okay, what was my, if I ask, okay, what is the first thing I asked? What is the first thing I told you? Let us see what it remembers. You were curious about salary, which I am still working on understanding. Would you give me to more context about that? Okay, so I hope we understand that, hey, we might have solved the cost problem there, where we are having a tight control over cost, where we can control our cost on the sliding window. Okay, this is the sliding window. We can set the sliding window. If we set 3 messages, 4 messages, the cost will be increased up to 4 or 5 messages. If we keep it up to 2 messages, the cost will be shrinked up to 2 messages. Okay, so when you want to maintain a tight cost control, that is when you go for this kind of memory. And this is a solution to the other memory. But what is the problem with it? Okay, best thing is it is cheap and fast. The cost never grows no matter how long the chat runs. But anything older than the sliding window, the information is gone completely, even if it matters. So here we are, moving on to a bigger problem, that we are losing important information. Okay, if let us say I'm telling this is my salary, this is how much I invest, and this is what I do. And last, when I tell generate me a investment plan given all of my salaries, it will not be able to do it because the salary message is gone out of the window. Okay. And this is what is sliding window memory. Okay. Now let us understand the third part, summary memory. Okay. Summary memory. Summary memory is also simple. Let us understand summary memory. So if I just go ahead and write summary memory. Okay. How it works is, first you gave a message. My name is XYZ. Okay. Then second, AI gave you a message. Then you ask a plan for your diet. AI gave you some message. Then you ask some another thing. How it will work is, the moment you ask something and you received a response, okay, this will be summarized in the user's name is this and user asked for this information. Then the moment you ask second question, then this summary will be again summarized. The user's name is this, the user has asked for a diet plan and I gave this response. Third, when you ask the next question that, give me a workout plan. So again, after the response is sent, third summary will be generated that the name of the user is this. The user is looking for a diet plan and this is the workout plan which I have suggested. Okay, so it will summarize. Let us see that in action. The idea is, instead of keeping the raw transcript, Nova keeps one running recap of each everything said so far. Okay, so let us see. Hi, I am Maya. It's nice to meet you. It's going to tell that nice to meet you too. If we check what's my name, it's going to remember that this is your name. I remember. Okay, I am Nova. I have a pet. Okay. I have a pet named Whiskers. Let us fire that. Okay. I have a pet cat named Whiskers. She's super fluffy. And let us see what's happening under the hood. Okay. Here, system message. And here is the recap of the conversation so far. The human asks for a quick check of their name. But since no conversation has occurred, the AI doesn't know the human name. The AI introduces as Noah. Okay. Something like this happened. See internally what is happening. The human asks for a quick check of name, new lines of conversation, and new summary. See, current summary, new lines of conversation, new summary. Okay, so for every new message, a summary will be generated. Okay, if I say, I love playing football. Okay, the moment I write, I love playing football, what's going to happen? Sounds like you enjoy staying active. This is the tokens, this is the cost, how it increases. And here, new summary, the human asks, etc., etc., introduces Noah. Then inquiring, she's playful and more relaxed. User, I love playing football. So this is how messages are being traced. Now, this is the new summary. Okay, this is the new summary. The human expresses their love for playing football, and Noah asks about the team or the position of choice. So how it is working is, it is trying to maintain the summaries after every messages so that, now they don't have to remember the chat history. They are not remembering the chat history just how we were remembering in the previous ones. Here we were remembering our chat history totally. Entire dump of our chat history was here. But now there will be only one thing, new user message and previous summary. Okay, so let me show you that. We will only have new user message. So new user message and new summary. Okay, always this will be the particular turn. But what is happening? One more thing. To convert the conversation into a summary, here also AI agent is involved behind this. AI agent will be making the particular summary. And that is why not one, two API calls are made this time. Because AI agent, first, it is giving a response based on the context. And second, it is also building the context by summarizing it. So AI agent is only summarizing this, right? So the best part is can hold the gist of very long conversation in few sentences, right? You tell me that, you give me many sentences that you are this person, you work here, you love this and that. I will just quickly tell, there is a guy named Divesh. He loves football and he is a teacher. In one line instead of 10 lines. Okay. 10 lines can always be summarized into, one or two lines. The best example of summarization memory is a book. Okay. Is a book. You know how a book is written of 1000 pages and it is all summarized in one page? Okay. Even though people read this, or even though people read this, they will understand the same thing together. But what will happen is, when we go on summarizing this, when we go on summarizing this, we are doing a bad thing. We are compressing the information. Okay. Compressing information. Because we are compressing information, we might lose out a important detail. Okay. We might uh, miss out an important detail which AI did not summarize, because here the control of summarization is in AI hands. AI thinks that is it important to summarize or is it not important to summarize. AI is the charge over here, in charge. If the AI did not summarize a very important detail because it thought that this is not important, we will lose our context. This is the first problem with this particular scenario. Okay, there is second problem with this particular scenario. The problem is called as context echo. Okay, context echo. For example, if a user is mentioning about football in every sentence, football, 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 okay, in from 100 sentences, let us say user has said football in 70 sentences, and the summary of this 100 sentences is in one paragraph. So in one paragraph, 40 to 50% words will be football. Okay, this is nothing but context echo. Okay, football might not be so important to repeat so many times, but because AI is in charge, which is deciding the summary, and because almost all the texts contain football, there is something called as context echo, that football is being highlighted, used a lot of times. So in order to tell about football 100 times, we might miss out on an important detail, and that is the drawback of summarization memory. So yeah, this was summarization memory. And next, we will understand about summary buffer. Let us now understand summary buffer memory. From this name, you can understand that this is a combination of summary memory and conversational buffer memory. We are combining both of these techniques to make a hybrid solution, because people were facing drawbacks one after the other. Now, to have a solution, we have this new kind of solution. People came up with new kind of technique, that how do we solve it. The idea is a hybrid. Nova keeps last couple of messages with proper understanding, and for the older messages it is creating a summary. So we are moving with the next one, which is called as conversational buffer memory. What is buffer? Buffer is a list of messages. Now how it works is, first I will have a message, second I will have another message. Okay, turn 1, turn 2. Here I can keep a threshold, that how much buffer I want to keep. So I can keep a buffer of 3. So after 3 turns, this entire will be summarized. Okay, this entire will be summarized and a new message will come. So for the fourth turn will get all the 3 conversations summary as input. Then fifth turn, then sixth turn. Okay, once the sixth turn is done, a total summary will be created from first, second, third, fourth, fifth, and sixth. Okay, where the new summary will be combined with the previous summary, because we want to summarize it, right? So this will be combined with this particular summary, and we are maintaining some summary buffer memory, where we will also maintain the exact chats of the user, but we will also go on updating our summary memory, so that we remember the near details. So we remember the short term details, And we also remember the long term details. So long term details will be remembered from summarization, and short term details will be remembered by this particular thing, by buffer. So here, what are we doing? We are also having a tight control over budget, and we are also maintaining context for a longer term, high period of context. Okay, let us see this in action. If I write, my name is Maya, it's nice to meet you, see what's going to happen. Okay, it's going to reply, it's fantastic to meet, one request, no one some cost. See here, recap of older messages. Currently, what happened? System message and first message, nothing has changed. Okay, because we are still in the context buffer, let me go for 3 4 messages. Okay, so she remembers my name. I will go for one more message. I will go for 4 5 messages. What's the fun fact about octopuses? What is the tallest mountain in the world? Okay, okay, what's my cat's name? It will remember. My favorite food is mango. I could eat it every day. Can you tell me a short joke? Now, after having so many messages, let us see what's happening down. See, currently we are maintaining the recent messages. These are the recent messages. User Nova, user Nova, user Nova. The latest 3 messages are being maintained. The 3 turns are being maintained, but rest we have summarized it. Okay. Maya introduces herself, confirms her name. So see, confirms her name. So 2 sentences were combined in one particular sentence itself. 2 turns were combined in one small sentence in 8 tokens. Okay. So similarly, summaries, this is how summary will help you. That change the color of the surroundings, etc. etc. See, summaries is generating. So here we balance both the words, sharp on the recent details and still keeps the gist going with the old stuff. But moving parts rather than each techniques alone so that it's harder to predict and tune. See people, what the problem over here is, what if the summary becomes too long? What if the summary becomes 2000, 10,000 words long? Okay, at that particular point of time our costs will go on increasing. We might have a small budget control, our cost will also increase of saving this particular summary. And hallucination will also come into the picture. Well, AI will start to forget what is happening. Okay, and this was summary buffer memory. Okay, let us understand the simpler one, token buffer memory. This is very simple. Okay, check this out. Tokens means the number of words. In this technique, what we do is, earlier we used to limit in sliding window. What we did, we were limiting with the number of turns, 2 turns, 3 turns, 4 turns, 5 turns. Here, instead of turns, we limit it to tokens, number of words, which means this is exactly same as sliding window, but only instead of turns, it will remember number of words. Okay, after 200 words, it will forget it. The rest of the information will be evicted. Okay, so see, if I keep it very smaller, let me reset this demo. If I keep it to 50 words, so hi, my name is Maya, 34 tokens are filled. Why? Because this all sums up to 34 tokens. And there is a system prompt also inside that. So this all sums up to 34 tokens. Now, if I ask a new question, what is my name? So it will remember this much. Okay. But again, if I give a message, I have a pet, I have a pet, I have a cat. Okay. See, you can see how much it is filling up. If I give one more response, okay, let me give one more. After doing all of this, okay, now if I ask, what is my name? Okay, let us see. Unfortunately, I don't have that information, but I will love to know your name. So, what just happened? Just how we were maintaining or we were evicting the messages in the sliding window, here also we are evicting the messages. See, what is the tallest mountain? It only remembers the last 50 tokens. Now why did we think of such solution? Because see, we were earlier in the sliding window, we were counting each turn. Okay. Now, even though a message was small or big, it was considered as a turn. Okay. So tokens were being lost like that. But this time, if a message is small, less tokens will be used. And if a message is big, then large tokens will be used. Here we can control the behavior of our AI agent, and we can tell that always give answer in under 200 words, so that we are inside our token window. Just how we had sliding window, now we have token window. All right. So again, the best part is we are able to save our costs with respect to sliding window efficiency. But again, the drawback is we are losing context. We are losing important recent context, and forget about long term. There is no such long term scenario here. Okay. The next kind of memory is vector store memory. Okay. Now, what is this? Let me tell you vector store memory. Okay. First, let us look at the example. Here, when we ask a question, similar information will be retrieved. Let us check that out. Python is the first programming language for beginners. Okay. Which is the first programming language? So see, Python, and this, it is coming in top two. Okay. Top two messages are this, depending upon the similarity score. Okay. What is cheetah? Cheetahs is fastest, etc., etc. Okay. Similarly, if I just simply write a keyword tower, Eiffel Tower will be the first ranked. Okay. What is this exactly? See, remember this point? When we were talking about sliding window, okay, we were evicting messages. Okay, just how it happens in Big Boss. Okay, we evict the consistents. We don't delete them. Okay, we evict them, which means they are out of the game. Similarly, we are maintaining a conversation history, and once it is out of the window, we will evict them. But after evicting them, we are still storing them in a database. Because if there will be a UI, okay, on that UI we want to show the chats, right? Even though internally it is forgetting, but on the UI we want to show the chats, and we want to maintain what user is saying or what user is asking. So we are not deleting the chat, we are still maintaining in the database. So if we are not deleting it, this entire information which we are storing is a waste. Why not utilize it? Okay, utilize it. So this is the motivation. But before that, people thought about using vector databases. Now, what is vector databases? Your sentence is, I am a cat. Okay. This sentence will be converted into a vector 0.8, 0.9, 0.7. If I ask, I am cat, my name is Divesh, I will just simply write. Okay. And if the second question will be, who is Divesh? So the top similar line will come into the picture, which is what we saw, right? This is what we saw. If I just simply write the most similar word, cat. Okay. So this will be the first, cat, and animals will be the second. See. Okay. Animals is the third. Never mind. Okay. But you can see cat is on the first because it is fetching the most similar relevant information. Now, vector store, introduction of vector store was the cheapest solution in the memory game. How? This time, we were not maintaining any summary. We were not maintaining any buffer. Directly, the moment user message is coming into the picture, it was directly, and the response as well. Okay. This was directly stored in a vector database. Okay. And every time a new user query will come, it will be fetched from the vector database. Okay. To fetch the relevant context. Just how we do it for RAG systems. Similarly, we were doing it for memory as well. Okay. And that is why you see vector databases in all the recent memory stores. That vector database will fetch the recent information for you. Okay. And this was the cheapest solution because vector databases are very cost friendly. Okay. Very cost friendly. So vector database was a solution. Okay. Here I am not talking about, maintaining any window, any sliding window, any buffer. No. Directly, the moment a message has come, it will be sent to a vector database. Yes, we can create a hybrid where vector databases will also be there and a buffer will also be there. So that is what I was saying, innovation. A hybrid can be there and people have implemented this hybrid. But directly it will be stored in vector database. So this is how it looks. Cat and etc. And even if you do about this, you can see how it is working. See, if I'm just passing different questions, it is just giving me response. Okay. And internally, see, what's the fun fact about octopuses? If I ask, what's my cat's name? Okay. What's my cat's name? Okay. And it can also, it can make a third hybrid also. I will talk about that. So if I ask, see, raw memory context. This is the raw memory context. Inputs, only inputs. Okay. This is how it looks in the vector database. And see, relevant memories. What's my cat's name? It will fetch some information from the vector database. Now, let me tell you about the third kind of hybrid. Okay. Third hybrid. We can also maintain a context window for short buffer. Okay. We can also maintain the information in a vector database. So the moment new user query is coming, the AI agent will search for the similar query in the vector database. And after the information is retrieved from vector database, this will be summarized first. And then it will be passed to the AI agent. And with all this summarized context, AI agent will give the response to the user. This is the third kind of hybrid which we can make. Okay. Just I'm talking about innovation. Innovation is nothing in this. Okay. Innovation here is just combining different techniques into one technique and just to see what it works. Okay. Whichever works is the best. All right. And this was about the third part or the second last part, vector store memory. Last one is the entity memory. Okay. Entity memory. Let us understand this entity memory first. So, entity memory refers to a very old NLP concept called as name entity recognition, where given a sentence, okay, my name is Devesh, okay, and my salary is 30,000. Okay, so what will happen is the moment I have passed my information, internally a map will be created. Name Devesh. And they can also maintain gender male. Okay, just in case if I've mentioned that, I'm trying to show you that how things are mapped internally. Gender male, work mentor, salary 30,000. Okay, so what it will do, given a user query, it will go on internally make these kind of entity maps. Okay, why entities? So name, gender, work, salary, these are different entities, and these entities will have different information for that. Okay, so now whenever a user sends a message, AI will dig into this particular entity memory, and from that it will give us the response. Okay, let us see that in action. So I can just simply write my name is Maya. Okay, and ask what's my name. So it will remember that your name is Maya and I am Nova. Okay. Here costs are increasing. Okay. Costs are also increasing. And that this turn made 8 API calls, not just one. This technique just did some extra steps behind the scene. Okay. Why? Because, you know, every time it is trying to map entities, AI is mapping those entities. and it is having some cost behind that. And you can also see this is costing us the highest. Okay, 4678 tokens in only this much, two messages. Okay, but information is accurate. Okay, information is accurate in that case. Okay, see, this is how it maintains conversation history, Maya. Okay, it is just maintaining some information is in this way. This is not displayed in the best way, but I hope you get the point that internally it is trying to make entities. Keeps every tiny, tidy profile facts which never grows huge, no matter how long you chat. But only remembers the things shaped like facts about a name. It is bad at, free flowing stories. It can match entities, okay? It can remember the contextual information like that, but it cannot remember free flowing stories. So, yes, this was all the different kind of basic memories: buffer memory, sliding window, summary buffer, token buffer, vector store, entity. You can always combine any of these memories to create a hybrid of them. Okay. And then lastly, you can see a comparison. Okay. This will run, full comparison for you. And in the end, it will give you a comparison. So 24 queries will run. And, once this is completed, you can see the comparison of how it looks like. And yes, that was all about different kind of agentic memory. And this is what we conclude for the first part of agentic memory. And that brings us to the end of part 1 of agentic memory, where we understood various kinds of agentic memory layers. And this all, trust me, are very important and can still be used in simple prototypes and anytime you need to implement in your use case on a smaller level. With this done, I am super excited to tell you that part 2 is coming as well. In part 2, we will study the advanced patterns, the advanced form of memories which are used in state of the art models. For example, episodic memory, semantic memory, procedural memory, and all those different kind of memories. So see you in the next part, students.